Welcome all. Now I am going to discuss question number 12 from the GATE 2020 paper Electrical Engineering. The question is thyristor T1 is triggered at an angle alpha and T2 is triggered at an angle 180 plus alpha in each cycle of the sinusoidal input voltage. Assume both thyristors to be ideal. To control the load power over the range 0 to 2 kilowatts, the minimum range of variation in alpha is. These are the given options. To know the detailed working principle of the single phase full wave AC voltage regulator, audience can go through the given NPTEL course or the video link. Let us have a brief discussion on the single phase AC voltage regulator. It is easy to analyze the circuit if we consider two cases. First case is when the supply voltage is positive. Second case is when the supply voltage is negative. When the supply voltage is positive, thyristor T1 is forward biased and T2 is reverse biased. So the load current direction should be like this, given that the thyristor T1 to be triggered. So if we give triggering pulse to the thyristor T1, it will start conducting. So the load voltage follows the source voltage and the load current follows the source current. Similarly, if we give triggering pulse to the T2 thyristor in the negative cycle, it will also follows the source voltage. Since the output voltage is looking like AC, right? So we need to find out the RMS value of the to get the output voltage expression. So which is given by V0 square is equal to 1 by pi integral alpha to pi Vm sin omega t whole square d omega t, where alpha is the triggering pulse to the thyristor T1. Let us solve the problem. We need to find out the minimum variation of the alpha, right? Range of alpha we need to find. And it is given that T1 is triggered at an angle alpha, T2 is triggered at an angle of 180 degrees plus alpha. And also the load power varies from 0 to 2 kilowatts. We need to find out the alpha range. So the output voltage of the AC wave voltage regulator is given by V0 RMS, right? This is. So V0 RMS square, it is equal to 1 by pi integral alpha to pi Vm sin omega t whole square into d omega t. Given the load is leading in nature, right? Load is leading in nature. How much it is leading? 60 degrees. That is minus 60 degrees. Since the load is leading in nature, we cannot control the output voltage from 0 to pi. We cannot control. We can control from 0 to pi minus small angle phi. This phi depends on the load angle. So for this circuit, the output voltage is given by V0 RMS square is equal to 1 by pi integral alpha to pi minus pi Pm sin omega t whole square d omega t. So Vm square is common. So we will take it as out by pi integral alpha to pi minus pi sin square omega t, we can write it as 1 minus cos 2 omega t by 2 into d omega t. So, Vm square by 2 constant. So, Vm square by limits are alpha to pi minus small angle phi 1 minus cos 2 omega t by 2 d omega t. So, Vm square by 2 pi integration of 1 is omega t minus integration of cos is sin, right? Sin 2 omega t by 2. The limits are alpha to pi minus pi. After substituting the limits, Vm square by 2 pi minus phi minus alpha minus 1 by 2 into sin 2 pi minus 2 phi minus sin 2 alpha. So, Vm square by 2 pi minus phi minus alpha minus 1 by 2 into sin 2 pi minus 2 phi plus 1 by 2 into sin 2 alpha. This is the RMS value of the load voltage, square of the RMS value of the load voltage. Power is equal to V RMS, V naught RMS square by R, right? So, power, when power should be 0, then V RMS square is 0. These two are interlinked. So, we need to equate the above expression to 0. That is pi minus phi minus alpha minus 1 by 2 into sin 2 pi minus 2 phi plus 1 by 2 sin 2 alpha. In the question, it is given that phi as 60 degrees, which implies pi by 3. After substituting the load angle, pi minus pi by 3 is 2 pi by 3, right? 0, right? So, 2 pi by 3 minus alpha minus 1 by 2 sin 2 pi minus 2 pi by 3 is 4 pi by 3. 4 pi by 3 plus 1 by 2 into sin 2 alpha. By looking at this equation, we can say when alpha is equal to 2 pi by 3, this whole expression is 0. This is also 0. So, alpha max is given by 2 pi by 3. We need to find out the alpha min. Alpha min we need to find out. Alpha min means load consumes maximum power. Max power. So, V naught RMS, again we need to find out, which is given by 1 by pi integral alpha to pi Vm sin omega t whole square d omega t. D omega t, right? Again, Vm square we will take it as out by pi. Sin square means it is 1 minus cos 2 omega t by 2, right? So 1 minus cos 2 omega t by 2 into d omega t. If we further simplify this expression, we will get Vm square by 2 pi. Integration of 1 is omega t. Integration of cos is sin 2 omega t by 2. Limits are alpha to pi. So, Vm square by 2 pi, after substituting the limits, pi minus alpha minus 1 by 2 sin 2 pi plus 1 by 2 sin 2 alpha. Sin 2 pi is 0, right? So, V naught RMS square is equal to Vm square by 2 pi minus alpha plus 1 by 2 sin 2 alpha. To find the minimum value of alpha such that the load consumes maximum power. Load consumes maximum power at particular value of alpha, at some particular alpha. This is the V naught RMS square expression. So, in order to find out the range of alpha when the load consumes maximum power. When load will consume maximum power, we need to take the derivative of the V naught RMS square. V naught RMS square with respect to alpha and equate it to 0 to get the particular value of alpha. Vm square by 2 pi, it is common and it is constant. Pi is constant 0, 0 minus 1 plus 1 by 2 into sin derivative is cos 2 alpha into 2 equal to 0. If we equate this term to 0 means cos 2 alpha minus 1 is equal to 0. So, cos 2 alpha is equal to 1 means 2 alpha is equal to 0, which implies alpha is equal to 0 degrees. So, alpha min is 0 degrees. Already we found out the alpha maximum. So, the range of alpha is, the range of alpha is 0 to 2 pi by 3. This is in radians, that is 0 to 120 degrees. The correct option is B, that is 0 to 120 degrees. Shortcut. Given it is single phase AC voltage regulator. If the load is resistive, R load. In the question it is given, it is leading load, right? How much it is leading? 60 degrees. So, the load current 60 degrees it will lead. So, the load current is like this, right? This is 60 degrees lead, this point. So, if we subtract 60 degrees out of 180 degrees, this is 120 degrees. So, we can control the triggering angle of the thyristor from 0 to 120 degrees.